Oh, this is a small word, model of human Pendrin protein. This also is how many? I don't know. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
When there is endocytosis happening, how you make sure that you are only taking the iodinated thyroglobulin and not non-iodinated? Is there any compartment?
The answer to that question is, that's a very good question. The answer to the question, it just takes it randomly.
Or are there any receptors?
No, I'll tell you, no. It just takes, that's a very good question. It takes, his question is, when the process of endocytosis is happening and the cell is taking in, are you sure that it's taking only T4, T3 or only tyrosine? The answer to that question, it can take anything. But if it takes tyrosine, it will be sent for processing again. If it is T3, T4, it may be used for sending it to the blood. You got it? Okay. So, this is a quick look at the Pendrin molecule, and let us see. We are still looking at, look at the beauty of this slide. We are again talking about what? I am sure you know what this is. We are looking at thyrocyte. Done? On the basal side, so this is what? This is the capillary. From the capillary, which molecule is coming? TSH, thyroid stimulating hormone. It acts on its receptor. And what kind of, I can see it going up and down 7 times. So, the G protein coupled system. Okay. And this is what? This is what? This is symport, this symport system. Okay. 13 times up and down. It will take sodium and iodine. And oh yeah, the author has drawn here, the pump has drawn here, author has drawn the pump here. Okay. And to make sure that sodium inside is low, so that this symport system can work. And then you have the and then you have, what do you have? You have the okay, and then this is the thyroglobulin molecule which is going here, and this is the iodine molecule. This is the iodine molecule is going there. Can you tell me the name of this system there? Pendrin. That's the protein Pendrin system. You are right. Now Pendrin, as it goes, okay, okay. The apical cell, the apical side of the thyrocytes is thrown into villi. Can you identify the villi there? Yes. That villi there, sitting on the villi, right on the villi. Okay, is an enzyme. Can you please read for me the name of that enzyme there? Thyroid what? Thyroid peroxidase. What is the name of the enzyme? Thyroid peroxidase. So, what thyroid and what is the message author wants to give here, that right on the villi is sitting this enzyme. The oxidation of the iodine is promoted by the enzyme thyroid peroxidase. Okay. So, that iodine has to undergo a little change there. Because of that little change, had that not happened, iodine can still combine with tyrosine, but at an extremely slow rate. Okay. That oxidation makes sure that the reaction really goes fast, and then as a result of that, we have thyroglobulin molecule. Do you find any iodine here? No. This has got iodinated, and as a result of that, you can get mono and diiodotyrosine molecules which are all over into the.
Sir, what does that arrow show?
Which one?
The top between two OH.
This is the, you mean, I am not getting your argument. You are talking about this arrow?
Top one, top this, between the OH.
I don't know that. It's chemistry, you deal with it. Okay. So, author tells us the importance of the peroxidase enzyme and oxidation, so that iodine can combine with this process is also called organification. Let us move on. So, okay, the pituitary has released TSH. Why has pituitary released the TSH? Pituitary, of course, steady TSH is always going. Okay. I suddenly put you in a cold place. So, there is a challenge on you. What is the challenge on you? That you need to maintain your body temperature. Okay. So, how do you realize it? Well, you have thermoreceptors. They are on your skin, they are on your hypothalamus. They tell your brain that there is an assault, there is a challenge with reference to temperature. It will trigger many things, including behavior. Okay. And then one of the important things it will do is to stimulate, is to tell the hypothalamus. Okay. Hypothalamus. Follow with me. Hypothalamus. Hypothalamus will release a peptide called as TRH. What is it called as? Thyrotropin releasing hormone. And this peptide is particularly interesting because it is made up of only 3 amino acids, one of the shortest peptides. How many amino acids?
3 only.
3, very short peptide, extremely short. And it is coming from the hypothalamus. It goes to the median eminence. Hello, are you with me? And in the median eminence, by way of hypothalamo-hypophyseal portal system into the anterior pituitary gland. In the anterior pituitary gland, you will have the TSH cells. Those TSH cells in their plasma membrane will have a receptor. The receptor is for TRH. That receptor is also 7-transmembrane G protein coupled system. Hello, are you with me? Very simple, same, biology is very repetitive, same thing, G protein coupled system, but the receptors are space, and then the cell will release TSH. Okay. Now, why is your system releasing TSH? Because your system wants, so that you can meet the challenge of the cold around you, you need to raise your metabolism. Okay. And the system that will help you to adjust your physiology to the lower environmental temperature is TSH and eventually T4 and then T3, and then it will have its effect on all the cells, so that metabolism everywhere will go up, so that now your body is capable of generating more heat, literally generate more heat. Okay. Okay. So we are looking at a follicle. Can you see the follicle there? This is interesting, just don't miss the point. Can you see the follicle there, single follicle there? When you look, can you see the colloid there in the middle? You find something interesting on the periphery of the colloid. Can you see there? There are certain punches, there are certain hollow areas. Okay, that hollow area is because these cells of the follicle will release enzymes. Those enzymes will chew up that part of the colloid, which means actually what? T3, T4. Okay, and take them by endocytosis. But when the hormone is being broken down in the colloid and being taken in, the colloid looks like this with these vacuoles, those holes. Those are actually not holes, we call them as vacuoles. What do they represent? Are you with me? So, there is a complete colloid. Let us see, we are looking at a resting thyroid. Okay, so far no problem, resting thyroid. No TSH, just resting. Now, suddenly the TSH started coming. So, thyroid is excited. So, thyrocyte is excited. What will it do? It will release enzyme. So, these cells will release enzyme. Originally, this was a smooth follicle, a smooth outline of the colloid. Now, under the influence of the enzymes, this part of the colloid is digested. Can you get my language? Broken down into what? A single T3, single T4, single T4, 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 T3, T4, maybe reverse T3, whatever. And then they are and then they are taken into the cell, but then this vacuole has remained. Occurrence of vacuole is a histological indication that thyroid is very active. Are you with me? Of course, one direct proof will be to take a blood and evaluate T3. That of course one proof is there. Okay, but other proof would be this indicates that the thyroid gland is active and under the stimulation of the TSH.
So,
okay, yeah.
So T3 and T4 was formed after proteolytic cleavage inside the cell. Right? So how are the enzymes working outside the cell and
In one slide it was.
You are referring to this?
one side before then I think.
This is same.
After the endocytosis, yeah, this one. After endocytosis process, proteolysis.
Yeah, this. You are talking about this, right? This, okay. Actually, it is not so hard and fast. It is this image doesn't really convey that. Or let me put it this way: the digestive enzymes will be released, T3, T4 will be broken down, and then taken in. Okay, so it doesn't really matter. I mean, you are asking whether it is broken down here, you are asking whether it is broken down here or here. Okay, that doesn't matter. That doesn't matter. What really happens is ignore this diagram, solve your problem. What is really happening is the enzyme is being released. That vacuole slide is correct. Okay, this is diagrammatic. Okay, the message here is the molecule is being taken in. Exactly where it is taking, what I am telling you is correct. It is happening in the colloid. In the colloid, that's where broken in, that's where it taken in, and that's what it is released. Your question is the thyroglobulin molecule being taken in the cell as it is? No, no. What is being taken is, get rid of whatever the image says. What is taken in is what? No confusion. Good.
So does TSH also stimulate release of more thyroglobulin in the,
Which, say that again?
does TSH also stimulate release of more thyroglobulin inside the?
Oh yeah. You are asking, does TSH promote the production of thyroglobulin within the thyrocyte? It promotes everything that is necessary for the formation of T3 and T4. Okay. Okay. Now one mistake correction. I made a mistake. I told you what? Thyroglobulin. That's correct. The protein that is there for the transport is called as what? Read here for me. Thyroid binding globin. I made a confusion there. So what? So I am talking of two proteins. Two proteins. One protein is tyrosine 70. Okay. What do you call it as?
Thyroglobulin.
Now T3 and T4 have come into the blood. Into the blood, they combine with a protein molecule. That protein molecule is called as what? Please read for me here.
Tyrosine binding.
Tyrosine binding protein. Okay. And actually we have seen this slide. So this is huge. Can you the molecule is very large. Can you see this tiny part? What is this tiny part? T4. What is it? The T4 is there. On entering the blood, over 99% of the tyrosine combines immediately with the several of the plasma proteins, and one of them is being the moment it combines, we actually know the reason for that. What would be the reason for that? To prolonging the half-life and the half-life of
Days.
yeah, you are absolutely correct. It's absolutely in days. Okay, somebody had asked a question as to where is the T4 bound to the globulin molecule in the blood? The answer is somewhere here. Let's see. So this is a thyroid binding protein or thyroid binding globulin. Huge molecule we have seen in the previous slide. It is bound to what? It's bound to what? T4. Okay. What about T3? Is it bound? It's not bound. It's free. Okay. The T3 can because it's only T3, it can easily flow out of the capillary. Can that larger molecule flow out? No, it is bound to the protein. Okay. So T3 can easily come out, or T4 can separate, okay, under the influence of deiodinases enzymes, and then T4 can come. But once it comes, T4 is again converted into what? T3. What is the message we have here? The message is simple. T4 is the storage part. Okay, its availability, it's an available part. But what is really dynamically important is
T3.
Is really T3. Oh, this is, yeah, look at this slide. T4 half-life is half-life itself is 6.2 days. So it will continue for another 10-15 days. I don't know how long. Half-life. No. If you inject 100 micrograms, it will be 50 by half-life is so much. Whereas the half-life of T3 is about how much? 1 day. But if you give if you inject radioactive what? T3 and T4, so much is then you still get it in the blood for a very long time. So you can, how many days will it survive? Almost 10 to 11 days you will get. What is the aim of this slide? Just to tell you that these hormones are very slow acting. They remain for a very long time, and of the two again, the T4 has much longer biological half-life as compared to what? T3. Okay.
Is there a mechanism for the kidney to reabsorb T3? Because 1 day is like a very big, even though it is a very
No. Yeah. T3 goes. It goes means it goes. There is no question of recovering it. See, the point is, at any given moment, the amount of T3 being given is very little. Okay, and what is given is one-way traffic. Okay, it can be there are deiodinases that can break down that iodine can be circulated. Iodine is circulated. Are you with me? Which means what? Let us take, okay, there is a cardiomyocyte in which the T3 has gone. In that cell, iodine has been removed. Okay, that iodine can go back to the blood. It can go back to the thyroid and it can be recirculated. Is the point well taken? So iodine can be recirculated, but the tyrosine will be metabolized, whatever, and it's a very slow, this hormone system is very slow acting. What do I mean by that? Is they say that you give an injection of a T3 or T4 to the rat, and for about 12 hours or 24 hours, nothing happens. Okay. And then slowly the rate of metabolism will start going up, and thyroid, oh, I am sorry, I am not even, how many days we are talking about? The rate of metabolism will go up after how many days? Peak at about how many days? 10 days, actually more than that. Okay. And then it will go down by about how much? By about, yeah. So it's a very slow acting system, because it activates a huge amount of enzymes. Okay. And they keep on generating the energy. Your capability to withstand the cold will be greatly compromised without T3 and T4. Get this point loud and clear. So, thyroid hormone increases transcription of a large number of genes. Most of the thyroxine secreted thyroid is T4, basal metabolic rate goes up. Let's go here, let's go here, let's go here. Basal metabolic rate goes up, let's go. Okay. Just one impact on the heart. We're looking at the heart. I'll draw your attention to the first image. Look at the heart, and that is the ECG there, diagrammatic for us, that serves the purpose. Is it a normal condition? Hypothyroidism, the thyroid has gone, and look at the ECG. Look at the hyperthyroid, okay, where too much is thyroid. Look at the ECG here. Can you get a clear difference between? So this is just heart. You will almost every organ, okay, you will find that it responds to the effect of what is this? This is hypothyroidism. The blood vessels stiffen there. Heart rate increases. This is not only the response which this is the strength of the response. This is the frequency with which heart is beating. Almost everything goes up under the influence of T3 and T4. Skeletal system, same hormone. Temperature regulation is most important. This figure, does it tell you anything? We have done it in the school. We are talking of frog. Okay, we have seen that the female frog will lay eggs in the pond. From the eggs, within a matter of a week or so, the eggs will hatch, and the tadpole will come out. And as we know, within a period of the tadpole will feed on the vegetation around. It will grow, and it will then what? Metamorphose, and then become an adult. We have done it. Yes or no? Yes. Good. That entire metamorphosis depends on one hormone, thyroid. What did I say?
Entire metamorphosis.
Just one hormone. And our classic experiment in endocrinology that has been done long time back is you get tadpoles. We can do it even here, even on the campus we can do it. In June, the month of July, you can collect tadpoles from the pond. All you need to do is to add what? No. Just in the bath, okay, in the jar, you add thiourea, okay. The thiourea, it binds with the iodine picking system, and then the animal is chemically thyroidectomized. Are you getting my language? Chemically, it is so small you can't surgically do it, but you don't need to. And when you remove the thyroid, obviously there is no T3, T4, and then as a result of that, the tadpole remains a tadpole, becomes very big, but still a tadpole. Okay, and to that animal, it's very, I mean, it actually becomes much larger, 5 times larger than a normal tadpole, but it is not able to metamorphose. On the other hand, if you take a tadpole and if you give it T3 or T4, which is available in a pharmacy, readily available, T3, T4 is very cheaply available, you will find that the tadpole will immediately metamorphose and you will get a tiny froglet. It is a frog, it is metamorphosed, it has lost its tail, its mouth parts are different, it can now feed insect, but it is very small. Okay. So, the classic if you want to demonstrate the classic beauty of endocrinology, you can just do it on the process of metamorphosis. Just one hormone is necessary for the process of metamorphosis. Okay. Anyway, let us look at it. We have any cell, T4 comes in, T4, can you read there? T4 comes in converted into T3, T3 can come in, that happens because of deiodinase. And then it goes, okay, so there is a receptor, the weak protein, it is generally, so there are two proteins, one is the different proteins, one is thyroid hormone receptor, it is with retinoid X receptor, the T3 will combine here, it will trigger a number of enzymes, and then as a result of that, what do I have here? I can read many other systems, growth, CNS development, cardiovascular, metabolism, so everything, sodium potassium pump, oxygen consumption, glucose absorption, everything, almost everything, every biological action you can think of is accelerated by way of this enzyme. This I will show you. We are looking at we have section through the pituitary of rat, step number 1, okay, and then I am going to show you staining with what? Its pituitary. So, TSH, we are going to take what? The antibodies against TSH. We are actually not going to take antibodies against TSH, but I will show you something more interesting. Listen to this. Wait. I have to retain your interest. No, this is really interesting. Look at this. I am talking of 4 different hormones. How many hormones? 4 different hormones. Okay. Out of that, 3 are from pituitary gland. What is this hormone? TSH. Okay so far? What is the other hormone? LH, we are going to talk about it, controls reproduction. Are you okay so far? What is the third hormone? FSH. So, FSH, LH and TSH, these are the 3 hormones, they are all secreted by what gland? Pituitary gland. Are you okay so far? The 4th hormone author talks about is the HCG. HCG is for what? Human, very good, chorionic. It is a hormone from the placenta. Are you okay with me? All these 4 hormones are dimers. There is a protein chain, they come together and you make the hormone. Okay. Now, I am going to make a very interesting look at the coding there in the image. Look at the coding there in the image. Across all the 4 hormones, alpha chain is same. Alpha chain, alpha chain, alpha chain, alpha chain, alpha chain is same. What is different is what?
Beta chain.
Different is what? Beta chain. Okay. Are you with me? So, for the specific activity, what is really important is the beta chain. Is what? Beta chain. So, what authors have done in the previous slide is they have isolated the beta chain. Got the point? They have isolated the beta chain, generated antibodies against the beta chain and used those antibodies to stain. If you had done the entire, then what you will have? You will have the pituitary in which you have labeled LH, FSH and TSH. Got the point? Therefore, you are not interested in making an antibody against alpha chain. You are interested in making antibody against beta chain, and therefore this is therefore now you can appreciate the wording here. Can you read what is written here? TSH beta amyloid cells in the pars distalis. Pars distalis is anterior pituitary. Pars distalis is what? We have done that. Anterior pituitary. Anterior pituitary is called as what? Pars distalis. Pars distalis. Okay. Posterior pituitary is also called as pars nervosa. Very good, very good. And these are the cells which are okay.